The Amazon rainforest is famous for its lush canopy, but the unmanaged soil underneath is surprisingly hostile, highly acidic, and notoriously difficult to farm. Yet, scattered throughout the basin are isolated pockets of deep, dark earth known as Terra Preta. These specific areas are intensely fertile, defying the harsh conditions of the surrounding landscape. Curious, these fertile zones did not form naturally. Indigenous peoples engineered them centuries ago, and they remain highly productive today. The secret to this lasting fertility is a stable, charcoal-like material called biochar. Terra Preta proves that soil fertility is not a fleeting, temporary state. It is an infrastructure that can be engineered to last for hundreds of years. Contrast that centuries-old permanence with modern agricultural struggles, particularly in places with sandy, nutrient-poor earth like Florida. Modern soils face two constant threats. Fresh organic matter decomposes rapidly in the heat, and heavy rains wash away expensive fertilizers in a process called nutrient leaching. When soil loses its physical structure, the resulting erosion collapses the landscape, sending valuable topsoil straight into local waterways. Without a stable internal network to hold moisture, crops in these depleted fields become highly vulnerable to sudden droughts and extreme weather. Modern agriculture is currently relying on temporary chemical fixes when the soil itself desperately requires a permanent structural upgrade. Creating that structural upgrade today relies on a manufacturing process called pyrolysis, which converts common agricultural waste or wood chips into biochar. It takes fast-rotting agricultural waste and locks its carbon into a permanent, weather-resistant material. As a result of this microscopic architecture, field studies show biochar yields sustained crop growth of 10 to 20%, alongside a 25% reduction in water runoff. Biochar's unique microscopic geometry alters the physical properties of the earth, directly solving the water and nutrient retention vulnerabilities of sandy agricultural land. Biochar is an amplifier. It reaches its full potential only when integrated with existing sound agricultural practices. Applying it is a deliberate, calculated re-engineering of the farm's foundational ecosystem. Because of this preparation and volume, biochar cannot be evaluated on a single-season return like a standard chemical input. It is a capital investment in soil infrastructure. The physical and chemical benefits persist, compounding across decades of growing seasons. While farmers secure their local crop resilience, the application also locks massive amounts of carbon safely underground, actively preventing greenhouse gas emissions. Applying this ancient Amazonian innovation through modern science secures the immediate harvest and constructs the foundation for the next century.